So now that you have received an overview of what the air quality demo does and how the code is organized, now let's have a look at what actually it produces in terms of data and output. So first of all, we start with the ingest job. So the ingest job does a daily ingest from the open air quality API and stores the data on S3. So here you see the S3 bucket. There's a folder called air quality, and inside there is a daily ingest partitioned by the ingest date for the past couple of months. So if you open the folder, you just see it's stored as a Parquet file. Now, in addition, this data is also, the metadata of this ingest is also stored in the glue catalog. So here you see the metadata of ingested data, so the column names and the data type, and this enables you to query the data on S3, so in a blob storage, directly through Athena without having to store it in a database. So this is on AWS. If you go to, for example, Azure, there you would store this metadata in the Azure data catalog. Now, after the ingest, a couple of things happen. So first of all, we send an email to subscribers to a certain SNS topic, that new data is available, that new data was ingested. And then these people receive an email that looks like this. So there are 10K rows ingested of Belgian air quality data on this date. Another thing that happens is we create a forecast. So based on the data that we have ingested today and the previous historically ingested data, we try to predict what the air quality in a certain location would be in the next couple of days. And for that, we use the Amazon Forecast API, which we also trigger on Datafy. So every day we create a new predictor. So this is basically a machine learning model that is offered by Amazon directly. So no need to create anything yourself. That takes into account all the data ingested, and then after it is created, you can create new forecasts. That's what we do here. So here we try to forecast the PM1 parameter for the next couple of days. PM1 in this case would be the smallest types of particles that would be in the air. It's actually the most unhealthy ones. And you will see that the forecast will try to predict for the next couple of days what the concentration in the air of that particles of that size would be. Now the forecast itself is of course garbage. We haven't really focused on creating a decent model. We're just trying to show you that it's very easy through Datafy to interact with multiple Amazon APIs and also with other tech stacks outside of Amazon. Another thing that happens is that we run a small Spark job. So the Spark job in this case just takes data, so it takes the latest ingested data, does a bit of transformation on top of it, like filtering or adding a new column, and then stores it back into an S3 bucket. So in this case, it would be in the Spark sample folder. And here you see again, it's been running for a couple of days, where the transformed data is stored back on S3 as Parquet files, a set of Parquet files, and also again now partitioned by a clean date, also stored in the Glue data catalog. And then finally, moving outside the Amazon tech stack, we also load ingested data to Snowflake. So Snowflake is not part of Amazon. It's running in a separate, it's running in a Snowflake cloud environment. And every single day we load the new ingested data into a table. So in this case, it's the AQ table. So this table here contains all the data that's also residing on S3, but now in a Snowflake table, so which makes it easy to query. And on top of this data, every single day we run a DBT model. So we have Python for the ingest jobs and for the forecast. We have Pyspark to do a small Spark cleaning / transformation job. And now we use DBT to run a SQL model on top of this data in Snowflake. So a lot of different languages, all running on the same platform in the same project. That's what Datafy enables you to do. And this model, and this DBT model, just tries to calculate a couple of daily means for all the parameters in the air quality data set and stores them inside a new table, in this case in the daily means table. And you can query that data as well, or with Snowflake allows you to create a shard of that data as well. but it is outside the Amazon tech stack. And finally, it's of course not wise to store database credentials hard-coded in your code. You always want to retrieve those type of parameters from somewhere else. So we're actually storing the login details of our Snowflake environment inside an Amazon secret, and during every dbt model run, or actually during every task that interacts with Snowflake, we retrieve these login details through the Amazon Secret Manager API. So I hope this gives you an overview of what the air quality demo looks like as an end result, and also hope that it will give you a bit more of an understanding of what Datafy enables you to do. So to recap, everything that can be built inside a Docker container can be run on top of Datafy. That's your only restriction.